The objective of this lesson is to create double number lines to solve ratio problems. In previous lessons, students used tape diagrams to solve problems using ratio pairs with whole and fractional units. In this lesson, students will use double number lines, which are best used when quantities have different units. They illustrate that there are an infinite number of equivalent ratio pairs, both with whole and fractional parts. Let's take a look at our first problem. A computer printer will print black and white copies at a rate of 14 pages per minute. How long will it take to print a document that is 70 pages long? Let's use a double number line to represent the data from the problem. We draw two number lines, one over the other, with one line representing the printed pages and one line representing the minutes. This problem uses different units, pages to minutes. So let's start by representing the ratio of pages to minutes at equal intervals on the number lines. The first partition is at 14 for the number of pages, and the first partition on the second line is 1 for the number of minutes. We need to continue to partition our number lines in equal intervals and follow the ratio pattern until we get to 70. 14 more pages is 28 pages printed in 2 minutes. 14 more pages would be 42 pages in 3 minutes. Another 14 is 56 pages in 4 minutes. And 14 more pages would be 70 pages in 5 minutes. So our answer is it would take 5 minutes to print 70 pages. Here's our next problem. A jet traveled 3,450 miles in 6 hours. How many miles did it travel in 2 hours? This problem compares miles traveled on a plane to hours it takes to travel. Using double number lines, we'll draw one line to represent miles flown and one line to represent the hours it takes. We'll partition our number lines into equal intervals following the ratio pattern. Could we find the number of miles flown in 1 hour or 1 unit? We might try dividing the total miles by 6. If we divide 3,450 by 6, we get 575 miles per hour. To find how many miles the jet traveled, we can add 575 plus 575 miles, which equals 1,150 miles. Could we also divide the total miles by 3 to find out the number of miles flown in 2 hours? We divide 3,450 by 3, which is 1,150 miles. We get the same answer whether we use repeated addition, multiplication, or division. The double number line helps us to see the different strategies we might use to solve the problem. Let's solve a new problem using our double number line models. Mario rides his bike at a speed of 18 miles per hour. How many miles will he cover in 4.5 hours? Using double number lines, we'll draw one line to represent the number of miles and the other line to represent the hours. We'll partition the number lines into equal intervals following the ratio pattern. 18 miles is 1 hour. Another 18 miles would be 36 miles in 2 hours. 18 more miles would be 54 miles in 3 hours. 18 more miles would be 72 miles in 4 hours. And another 18 miles would be 90 miles in 5 hours. Since the problem asks how many miles Mario biked in 4.5 hours, the number of miles would be halfway between 4 and 5. Since each interval represents 18 miles, 1/2 of an interval would be 9. The number of miles Mario biked in 4.5 hours is 81 miles. Students will continue to work with a variety of real-world problems and practice using double number lines as a strategy for solving ratio problems where the quantities have different units. The objective of this lesson was to create double number lines to solve ratio problems. We met this objective by drawing and partitioning double number lines to help determine the computation needed to solve problems. Throughout the lesson, students are asked to describe the process for setting up their models and share and justify their thinking and solutions.